again, when vectors, remember everything in vectors or in physics is either a vector or scalar. And when we're looking at vectors, and vectors are represented as arrows in physics, all right? And so when they are in the same direction, we're going to add them together. And when they are in opposite directions, we're going to subtract them. And that was the whole purpose of the notes earlier this week. Vectors in same directions, we add them. Vectors in opposite directions, we subtract them. Kind of like going up, the velocity is a vector and it's going upwards, but yet gravity is going downwards. Those are opposite directions. That's the reason why when an object is tossed up, it actually slows down. But it slows down not because if you answer, oh, it loses momentum, or it loses velocity, or the air resistance is causing it to slow down. That has nothing to do with it. The true reason why is because objects that are in two separate vector directions are going to mathematically subtract and slow down. Objects that are moving, or an object that's moving where the vectors are in the same direction, like this one, and this number 2 was screwed up. It supposed to belong to that arrow, so I'm not sure if that was recognizable. So when vectors are in the same direction, then you add them together. So pretty easy cheesy when it comes to that portion of physics. So kind of like if you're running and you're running, let's say you're playing soccer, and you're going with the wind or with the direction of the wind, your soccer ball, when you kick it, is going to go a little bit further than if you're going in the opposite direction against the wind. Those are vectors. Vectors in the same direction. One more time, you're going to add them together. So this one's 3n. N was actually represented as the SI unit. We haven't talked about that SI unit yet. We will in this unit. It's called a Newton. It's named after Sir Isaac Newton. So 3 n's, and your vector arrow should be roughly, give or take, these two lengths added together. So your vector arrow needs to be proportional to the actual value of that vector. So if this is 3n, the next vector, by any chance, if it's 4 or 5n, should be longer. If it's 1 or 2n, then it needs to be shorter than what I'm starting off as my 3 vector arrow. So they need to be proportional. Vectors that are in opposite directions, we subtract them, and it's 0n. Even 0 has an SI unit, n for Newton, but we would not draw an arrow because there's no vector that correlates or goes along with that one. Your next homework question, again, they are opposite directions. We're going to subtract them. So 2 take away 1 is 1, 1n, and it would be in this direction. And when you draw your vectors for your quiz, I should be able to tell, not that I'm getting a ruler out because I don't have that kind of time, but with my eyes, I can tell that this vector arrow is definitely longer than this vector arrow. This vector needs to be proportional to the number 1, so smaller. This vector needs to be proportional to the number 3, so it should be larger. Then we get into some math questions over here, which is a review because that's where I noticed some students in these past years have starting to wonder, like, or not do so hot was because of the math. So let's look at some more math to practice. It says a bicycle increases speed from, okay, if it's from anything, that's my initial, to, that's my final velocity. Oh, there should have been a better space than this over here. It took 12 inches. What? 12 inches over here in 16 seconds. So let's go ahead and let's say this is my time and this right here is my distance. A horrible distance, 12 inches. What is the acceleration? Question mark A is what I'm looking for. Well, first thing is, we're going through the flow chart, and the flow chart asks, was distance ever used, involved, discussed, looked for, anything? And the true answer is yes, because when you wrote out all of your variables over here on the side, VI, VF, D, T, and A, they actually did give it to me. They gave me that distance of, and it's horrible spacing, 12 inches. The T was 16 seconds. The A was my unknown. The VF and the VI was given to me as well. So actually, 4 out of the 5, which is pretty awesome. Rarely do I get 4 out of the 5. Traditionally, I get 3 out of the 5. But in this situation, was distance ever used? Yes. Was T ever used? Absolutely it was. It was given to me as 16 seconds. But the question here says, well, what is my acceleration? Again, the flow chart is pretty darn good, but it's not 100% proof. I've never said that that flow chart is 100% proof. Remember, you are smarter than the calculator. You are smarter than that flow chart. So for this situation, A, before I get into that equation of D equals VI times T plus 1/2 AT squared, I know that my easy cheesy, remember those 3 originals from Unit 1? Those originals, A equals VF minus VI over T. No needing for distance at all. And so truly, I hope that you go ahead and figured this out, that, yeah, that flow chart is pretty good, but, you know, it's not perfect. So 12 take away 4 over 16 seconds. So that distance that was in inches was extra junk to throw you off. I mean, if we did need it to, then in this situation, we would have to convert the inches into meters, kind of like you did in chemistry class for dimensional analysis, but that's actually truly something I would never ask you to do. I would give you that information here in physics. I wouldn't ask you, never ask you on a quiz for you to figure that out. That was just extra numbers to throw you off. So in that situation, 12 take away 4 comes out to 8 divided by 16. Your SI unit, again, velocities in meters per second, which is great, and my T is in seconds. If my T was in minutes, which I would maybe do at one time, then I would have to convert it to seconds by getting whatever minutes multiplying by whatever 60 seconds in a minute. But for this situation, your SI units would be meters per second square. So I'm pretty sure you probably did that. Yes, did I mess up?
I don't think the 12 is supposed to be in there.
Oh, I'm so sorry. Whoa. What do you mean the 12?
The 12, there's no distance. That's a duplicate of the 12 from the VT.
From the VF?
Yeah.
You know, it was actually supposed to be, oh, I see what you're saying, that 12 versus it's saying 12 inches. It should have just been in 16 seconds. I should have did a better job in writing that. There you go. I should have did a better job in writing that and saying 12 inches and it took 16 seconds or something like that. My wording should have been a lot better. I completely agree with you, because if not, it looks like that 12 was just a duplicate. I agree with Noah 100%. So do I throw extra numbers? I do. Most of the time I throw extra numbers as in degrees. Really would I do that as well. So it looks like it's absolutely a duplicate. I agree 100%. Hopefully you did get that 8 divided by 16. Meters per second square is your SI unit for that acceleration. What I did need us to see, though, is that, that easy cheesy equation does come back at times, and it helps us out by knowing that information from that easy cheesy Unit 1 stuff. Next one, number 2, or the second math problem, looking at this one. Let's see if I made a mistake on this one. A dog stops. So if anything comes to a stop, it's going to have a final velocity, and it's going to be 0. A dog stops in front of his doghouse. Now, it did take 3.5 seconds for T and had an initial velocity, VI, of 3.75 meters per second. What was, question mark, the acceleration? Oh, this one's definitely written a lot better. This one, I'm going to still go ahead. I know I don't need this, but I'm going to go ahead and just write my variables because it's good practice. Because like I said, we are about to get to 8 variables soon. Right now we have 5 variables. We're about to increase it to 8 pretty soon. So VI here is 0. Oh, so sorry. VF is 0. VI is 3.75. Distance was never given. T was 3.5. A is my unknown. Going through the flow chart, it's asking me, was distance ever used? And that's a no, because I can see it over here. In this situation, A equals VF minus VI over T. It's still the easy, cheesy equation of 0 minus 3.75 over 3.5 seconds equals blank meters per second square. All right, so hopefully that's how you set it up. If you did, then you probably got the right answer, even though I'm not giving it to us right this moment. Next one over here, a car stops. Oh, there goes another object that comes to a stop. So that means that the VF is 0, and it took a distance of 120 meters for it to come to a complete stop. If it had this negative acceleration, which is -5 meters per second square, how long, question mark T, how much time did it take for it to come to a stop? Again, I'm going to pause and write down my variables, VI, VF, D, T, and A, because it's going to help me organize my variables. Like I said, we're going to get to 8 variables pretty soon. Now, it looks like when I identified my variables, they didn't give me anything over VI, so I'm going to put an X there. VF was 0 because it came to a stop. Distance was 120 meters. T is my unknown, and A is my -5. For traditional kinematics, you are missing 2 variables, which we are, VI and I'm missing T. Going through my flow chart, was distance ever used, talked about, or discussed? Yes. And I get some students, when we're still kind of practicing that flow chart, we get a little confused on this part. Was T ever used, talked about, given, or looked for? Yes, T was. T is actually looked for. I'm actually looking for T, but don't forget, remember, earlier this week, I did a 2-step equation or a 2-step problem because I forgot, and let me go back because I don't do kinematics for the fun of it over the summer. I go back and redo kinematics with you every single year, all my students. Was VI given to us? Because that's what the flow chart says next. No, VI was not given to us, right? VF was given to us. So in this situation, instead of using the VI or that first equation over here, because VI was not given to us, VF was given to us, that memorized equation of distance equals VF, multiply it by T, subtract, not add, subtract 1/2 AT squared. The great thing about this one is that VF, yes, was given to us, but VF is a 0. So to be honest, I can just cancel that part out, but I cannot cancel out the negative. Let me double check before I go any further. D, yes, I have it. 1/2, yes, that's a 0.5. A, yes, I have it. And T is my question. So looking at this algebraically, this should be the right equation for us to utilize. And don't forget, we can cross out that first part if you're pretty math savvy. You don't even have to write that in. The only thing is, please don't cross out that negative, because that negative is part of all of those variables that are being multiplied. Okay? Now, I'm looking for T. And knowing that Ms. Munson said that if we're looking for a T variable, our T can never be a negative answer, right? So keep that in mind, that your answer should be positive, okay? Tossing that out there. Now let me go ahead and fill in my variables of 120 equals a negative, because I cannot get rid of that negative, 0.5 times a -5, multiply that by T squared. All right, T squared, because I can't forget to square that. And I know that before I even finish, because T is my unknown variable, I need to square root that. So put that in the back of your mind too when you're doing this math, okay? So in this situation, let me go ahead and do what I could do, which is these two numbers over here. I have a -5, and I'm going to multiply it by 0.5, which has a negative in front of it, and you know a negative and a negative is going to become a positive, which is good because my t should be positive. So I get 120 equals 2.5 positive. I can cancel out those negatives, which is great, times t squared. I still do not have t by itself, and so in this situation, I'm going to divide by 2.5. I hope you did that for your homework, right? 120 divided by 2.5 for this situation comes out to 48 equals t squared. Not my answer, because I need to get the t, not the t squared. So in this situation, I'm going to hit second key square root of 48. I end up with a t value. I'm just going to put a little arrow for those of us who are looking at this later on. A t value of 6.93 seconds. I mean, some of you, I know I did see somebody who rounded it to 7 seconds. No problem. I absolutely would give you complete credit, especially since you did the work this way. But it looks like it came out pretty good. Turn the page, unless we have questions on that, and always double check my math. We talked about this earlier this week. Talk about an object. Now, this actual situation, we were tossing, here's the ball that we were tossing up in the air earlier this week. The moment that it leaves my hand, whether it was this or we gave the example earlier this week of a bullet, the moment that anything, if you're throwing a baseball, if you're throwing a football, if you're kicking a soccer ball, whatever it is, the moment that it's no longer touching the ground and it's in the middle of the air, toss it up, I was not touching it. The moment it leaves my hand, we call those situations free fall. One more time. We were talking about free fall. I didn't use that word earlier this week, but now we're going to toss that word in, okay? Because I'm trying to step us into this physics stuff. So the moment it leaves my hand, it's in free fall. Oh, damn. Got it. Got it. Here we go. So I have to stop for a moment and think about, okay, the force of my hand caused it to go up. And in physics, just like in math class, an object going up, like up on a graph, is positive. So when I tossed it up, the velocity from that force of my hand was in the upward positive velocity. The only thing touching it, and let's just disregard air molecules. Disregard air molecules. We are not going to consider air. Now, I mean, I guess if you're going to go into engineering and you want to be an astrophysicist, which is awesome, and work at NASA or wherever one day, SpaceX, great. Then yes, you're going to consider the friction of air molecules. But at this point, we're going to cancel out all air molecules. The moment that this leaves my hand, it's not touching anything, but there is a force that is touching it. And that force, even if I was not to throw it up, if I was just to move my hand, it would still fall down because the gravitational force. So any object that's not touching or sitting on a table like that, or on the floor, or does not have any kind of force touching it, the force of the table touching it, any object that doesn't have an outside force touching it, that's just here in the air, has what we call, or what it is in free fall. And gravity is the only force at that time touching it. So that's what we were talking about over here earlier this week, and that's what this homework question is. Question number 1 says, a ball is thrown vertically upwards with an initial velocity of 12 meters per second. That upwards, or if we stop for a moment and draw a line in the middle of that parabola, oh yeah, we're going to start using that word soon. Of the parabola, the first half of the parabola going up has a positive velocity vector. It's moving in one direction up. But the moment that this ball was tossed upwards, it left whatever it was, somebody's hand or whatever it was, and the only thing touching it at that moment, A, B, C, D, E, is gravity. Gravity is the only thing touching it at that time. We call situations like that free fall. Alrighty? And so while it's in free fall and it has an initial velocity of a positive 12 meters per second, the positive only identifies the direction. What is the velocity and deceleration for every A, B, C, D point that is here? So if it is a acceleration, it doesn't matter if it's going up, if it's at the top, or if it's coming down. Acceleration is negative 9.81 meters per second square. Negative 9.81 meters per second square. Negative 9.81 meters per second square. Yes, I'm adding my SI unit, and yes, I'm adding a negative. I'm adding that negative because that negative is identifying the direction of the vector. One more time. The negative is identifying that direction of the vector, which is a downward direction, which is opposite of the positive vector. They're moving in opposite directions. So that's indicating to me in my mind that when I have vectors in opposite directions, I'm going to just subtract them. Easy cheesy math. Now, they didn't give me all of the blanks. They left some of them empty for me. And I can see that on this side, at the exact location, by any chance, if those B and D were at different positions, the numbers would not be the same. But since they're at the same exact position or location going up on the parabola versus going down on the parabola, if this is a -4, this is a +4 meters per second. And yes, I add my units because I don't want to leave a number without a unit because it has no meaning or value. This one is a +12, and they told me it's starting with a +12. This is a -12, but it doesn't mean negative value, like, oh, you owe $12. No, it just means negative direction, which is a downward direction. And we talked about this location. That position at the top of the parabola, or that peak location, has a name. It's called non-zero acceleration. That's going to be super important later on when we do our math equations, because non-zero acceleration has two numbers with it always. One more time. If they're talking about the top peak of a parabola, that already clues me into two numbers that's given to me. They don't even have to say those numbers because I know in physics that at the top of parabola, there are two numbers that are always a guarantee. Number one, acceleration, which I already wrote down, is a -9.81. So when I toss my object upwards, it literally leaves my hand with a positive velocity moving upwards. It slows down. Why? Not the wrong answer, because it loses momentum. Absolutely the wrong answer. The correct answer in physics is why does it slow down at the top? Because the vectors are in opposite directions and you subtract them. And so that's why it's slowing down. When it gets to the top of that parabola, it literally, and it's so hard to tell because it happens so fast, but it literally comes to a stop. And the reason why it comes to a stop is because it has to stop going up and it has to start going down. Okay, one more time. It has to stop going up and it has to start coming down. And so it loses, quote unquote, velocity because the vectors are in opposite direction. My velocity, you don't even have to tell me. I know always at the top peak, which is called non-zero acceleration, is always going to have a zero velocity, but a -9.81. So it says here, what is the velocity at the top for this ball over here? 0 meters per second. What is the acceleration at the top? -9.81. What is the final velocity and deceleration of the ball just before it hits the ground? Well, that final velocity is a -12, and the acceleration is a negative also. And that's the reason why it starts to, quote unquote, speed up. It starts to speed up because the two vectors are in the same direction. And we know in physics that when arrows or vector arrows are in the same direction, we add them together. So if the velocity up here at the top of the peak started at 0, the velocity is going to increase. Okay, it actually increases to the same amount. And remember, in our notes earlier this week, we said that if you allow that ball or that object to have more time to fall, then it's going to even increase more of a velocity. And it says over here, I don't know why it says your name. If a hole is in this actual ground and the ball in this falls into that hole. So for an example, if this is the ground, but actually there was a hole that was dug deep in this ground now, and this ball was to continue down, to fall down into it, what would the final velocity be? It would be greater than, and this is where some students kind of get a little like misconception, it would be greater than negative 12 meters per second. Do not think of a number line, okay? Think of this negative only means direction. So it would be negative 13, it would be negative 14. It would increase velocity because the two vectors are being added together. So it would be greater than negative 12 meters per second. Again, I get some students who get that misconception from like their math class confused with physics. Next one over here, a coin is tossed upwards. Okay, we talked about objects going upwards. What happens to the velocity as it moves upwards? The velocity is going to decrease. Does the coin's acceleration on the way up increase, decrease, or stays the same? The actual acceleration stays the same. And that acceleration comes from gravity. Gravity's acceleration does not care the size. It could be a coin or it can be a car falling off of a cliff. Gravity is going to have that same number of negative 9.81 meters per second, no matter the size of that object. Two children are bouncing rubber balls. Now, one child simply drops it. At the same time, the other child throws it downward with this initial velocity. What is the acceleration for each of them while they are in motion in the air? Remember, the moment that it's released from your hands, I don't care if it's released from this super tall building or if it's just released from my hands, and I'm 5'2" with shoes on. Does not matter the distance or location, as long as it's in a reasonable, within our atmosphere. It's going to still be the same of negative 9.81 meters per second square. Whether you throw it with a force downwards, like, well, that's an initial velocity that you're tossing it downwards. Again, the moment it's released out of your hand, it's called a free fall, and the acceleration is the same. I know it's kind of hard to believe, but that is true. Gravity does not care and has no bias on whether you give it a force or whether you just drop it. It doesn't matter. Next one, a baseball player throws a baseball straight up into the air. It says here, what is the numerical value for the acceleration as it's going on the way up? Well, negative 9.81 meters per second square. At the top, negative 9.81 meters per second square. And on the way down, again, hopefully you can tell that this homework is trying to drill that negative 9.81 into your head. Again, whether you were walking and you say, oops, I accidentally dropped it, whether you tossed it upwards, or whether you forcefully tossed it down, the moment it leaves your hand, gravity is always going to have an acceleration. It's called a free fall equation of negative 9.81, and it doesn't care. It has no care on the size, the mass, or the initial velocity. Does not care. A car travels, it says here, 18 meters per second and accelerates uniformly. Okay, obviously that's a velocity, but I'm going to wait till I read some more. For 10 seconds, T. How far, question mark, distance, does this travel during this time? So if it's accelerating, and I definitely see that it's a positive acceleration, so it's probably more than likely going to speed up, not slow down to a stop. And in physics, there's very few assumptions we can do. But we can always assume that if they're talking about it currently, and something's going to happen in the future, like how far is this distance going to occur, my current situation is a VI. Okay? We need to take that into our gut, whether we like it or not. That is my VI, not a VF. Now, my next way or the next step of what I personally like to do, again, you do not have to do this. I will not take points off, but I can't really help you if I don't have, if you don't have like your variables and numbers organized when you come and ask me for help. Like, I don't know what you've got. Here's how I like to organize myself when it comes to these numbers. VI is 18, but when I look at those variables, I don't see any VF, so I'm going to put an X. Distance is my question. A is a 2, and T is 10 seconds. Okay, if T was in minutes, I would need to convert it. Okay, so I'm looking for my distance, and my distance is going to be in meters. Why is it going to be an answer in meters? Because my acceleration and my velocity are in meters. What if the question on the test online says, what is the distance in kilometers? Then when you get your answer, please make sure you convert it to kilometers, if that was the question. But here, using the flow chart, was distance ever used, talked about, discussed, or looked for? Yes, it was. It's my unknown. Was T ever talked about? Yes. And was VI given to me? Yes. Those are the three questions of the flow chart. So for this situation, my equation is D equals VI times T plus 1/2 AT squared. Okay, let's double check just to make sure if I can use this equation. D, question mark, VI, check, T, check, 1/2, check, A, check, T, check. Not only can I use this algebraically, because I'm only missing one variable, the great thing is once I do the problem, that variable is my unknown that I'm looking for. So let's go ahead and let's do that. Distance equals 18 multiplied by 10 plus, change that to a decimal, times A of 2 times 10 squared. Don't forget to square that 10. That's like my weakness, is forgetting that little square. So let's go ahead and let's get this done. 10 times 10, or 10 squared is 100, times 2 is 200. Multiply it by 0.5 is 100 again. Tell me if my math is wrong, but that's what I'm doing my math in my head. I do not know, well, would that be 180? Noah? 18 times 10, right?
Yes.
Should be, right? I can't even do simple math. Plus 100. I come up with a distance of 280 meters. Double check your math. Hopefully that's what you got. Hopefully those are the steps that you did. Okay, so that's homework number 2. We have homework number 3 that we need to talk about and look at because tomorrow is Friday. Let's look at homework number 3 so that way we kind of know where we're going to go with our general notes. It looks like we're going to get into SOHCAHTOA, or I'm not sure with your math class if you talked about right triangles. That's what we're going to talk about right now. Right triangles. We need to talk about right triangles so that way we can get into parabolas. So right triangles is what we're going to talk about. Then after that, it looks like you're definitely going to need your calculator because unless you know all of the sine, cosine, and tans, thetas in your head memorized. I personally don't. I use the calculator. Okay? Then it looks like there's some more right triangles, and then there's some questions over here. Let's see, that talks about, we've got the speed of a bullet traveling. We also are over here talking about the end of a ramp going up. How high is it at the end? I think we should be able to do these. Yep, we should. These are going to be SOHCAHTOA and Pythagorean equations. So in our notes, we need to make sure that we cover that information. So we do skip around in our notes so that way our notes can cover our homework. here we go. Here's what we've done so far. We did skip this. We need to come back to do some more practice problems. No issues. This, we start talking about the word free fall. Remember, I just talked about that. The moment that an object is in the air with nothing under it, like you don't have a chair, your chair fell out because it broke and now you're falling. That's called a free fall equation. All right, so we talked about that, what a velocity as well as an acceleration look like. But that is due to the vectors being in an opposite direction or the vectors in the same direction. Turn the page again. Then we talked about vectors and just simplified. When vectors are in same direction or vectors are in opposite directions, you are going to add them or subtract them. But what happens when vectors become in a right triangle? We've got one going up and one going to the left, and now we have a right triangle. So that's what we're getting into now. Vectors that are going to turn into what we call right triangles. So let's go ahead and let's take a glance at that. It says, well, let's look at this problem over here. So let me zoom in just in case. What would the direction of the resultant vector? Oh, there goes a different word. The resultant vector is the overall answer or direction. One more time. What would the direction of the resultant vector for this picture below? If you start here, you go to A, whatever building that is, and then after that, then you go to B, I don't know, maybe that's school, or it's a building with a flag. Overall, if you were able to shortcut it, if that makes sense, if you're able to shortcut it and just where is the overall direction you ended up traveling, this upward would be my resultant vector. All right, that's just what direction, what displacement would you have? Think of it that way, as a displacement. Now let's go to this next part over here. Well, sometimes vectors in what we call 2D motion are at a right triangle. Oh, we're about to get to those right triangles. Imagine if you were a tourist climbing up this pyramid. Now, this tourist, it says here, knows the height of the pyramid and knows the base width of the pyramid. And it also says here that the tourist would like to know the distance that they're going to cover if they go from the bottom to the top of the pyramid. Well, what equation would you use if this was you right here, the person, and you wanted to walk from the bottom of the pyramid to the top of the pyramid? And you can see that right here, it forms a right triangle. Well, hopefully in your mind, everybody's saying, oh, well, that's Pythagorean. Thank goodness you know that from your great, amazing math teachers. A squared plus B squared equals C squared. Or we all know that C squared is that hypotenuse. And A squared and B squared are going to be one of the legs, right? So I'm going to call this leg number 1 and leg number 2. Okay, leg number 1 and leg number 2. Now, right below that, it says, okay, well, let's put that Pythagorean that you know already into play. It says, well, now find out the actual distance that you would need so that way you can climb the top of the pyramid. Well, in this situation, I need to start drawing it out because I need to make sure that I know exactly what I'm talking about. I'm a visual person. I like to see it so I can do it, so I can get this math done. Here it is. I'm over here in Egypt, it says, and I'm over here at the bottom of this pyramid. And I'm about to go and climb up this pyramid. That is my resultant vector. That is my resultant vector. They did tell me that the height of the pyramid, because they told me that up here, they told me that the height of this pyramid is 138.8 meters. They also told me the width of the pyramid. I'm going to zoom out a little bit so we can see those numbers from the top. They told me that the width of the pyramid is 230.4 meters. Thank goodness both of those are in meters. If not, we would need to convert one or the other. So would it just be a squared plus b squared equals c squared? I mean, easy cheesy. Thank you. I'm so glad you said that because somebody would not remember that. We've got to cut this base in half. And so rather than it being 230.4 as one of your legs, please don't make that mistake. It's actually going to be 115.2 and this side is 115.2. Please do not get that portion confused when you're doing a quiz or a test. You are smarter than any calculator. You need to remember that you've got to cut the base in half. Now, when we do a squared plus b squared equals c squared, this is the leg that we're looking for right here. That is my unknown leg. And you know that when it comes to that leg is your c or your hypotenuse. This is going to be leg A and leg B, however you want to call it. So I'm going to go ahead and just say it does not matter which way you put it in the calculator. 115 squared, do not forget to square it, plus 138.8 squared equals c squared. Or I went ahead and squared it, double check my math from last year, 13271.04 plus 19265.44 equals c squared. I'm going to do it step by step. I'm sure you can plug it all in to one quick equation. But I get 3253.6.48 equals c squared, which is not going to cut it because I definitely need that square root of it. So for that situation, when I square root it, I end up with the number of, let's square root this because I need c by itself. C comes out to 180, and you know that the hypotenuse is always the longest leg, 180.37 meters. There you go. 180.37 meters is how far of a distance all the way up. This must be a massive, massive big pyramid. All righty. So just pulling in that Pythagorean that you used prior is what we're doing here. Next one, it says here's another example to take a glance at. It says a truck driver attempting to deliver some furniture travels 8 kilometers east, turns around and travels 3 kilometers west, and then travels 12 more kilometers east. What was his destination? Or what would, for example, letter A, what would his path look like? What was his total distance? Remember, distance means to add. And what is the driver's displacement? Okay, so in this situation, let me go ahead and draw it out, letter A. So for letter A, it says that first, this driver went 8 kilometers. And I don't have to write the word west. Or east, I'm sorry. I don't have to write the word east because the arrow represents that. But I am drawing my arrow that distance. That means that if I need to draw a 17 vector arrow, then my 17 better be longer than the 8. If I need to draw a 3, it better be less than half of the 8. So when you're drawing, then they need to be proportional. Then after the 8, this driver turns around and does 3 kilometers west. So at this moment, this is where they went to. So I'm going to come over here and I'm going to draw 3 kilometers. But wait a minute, this was messed up. Turn around, you got messed up on your GPS, go 12 kilometers east. Oh man. I feel bad. I hope you gave yourself more space There. Woo! Okay. I feel better. I can't just get this arrow and draw it over here. This is where he stopped and turned around. So this one should be longer than the 8, and longer than the 3. The 3 should be smaller than the 8. So I went ahead and just took some off the end real quick. This is what the drawing should look like. Number 1, that's letter A. Letter B, what was the driver's distance? Well, if this distance right here was 12 plus 8, which comes out to 20, plus 3, hopefully you got 23 kilometers, was the total distance traveled. Think about how much gas totally they used. What is the driver's total displacement? Displacement is from the start to the end. From the start to the end. This is the displacement. So if they traveled 8, turn around and take 3 off of that 8, this becomes 5. 5, and at this location goes another 12. 5 plus 12 is, hopefully you have, 17 kilometers. And then they said, draw it as an arrow or vector form. My 17 should be longer than the 12, so let's see. Something like that. So it's adding the distance of this plus this to get the 17. Okay, not a problem. We're just practicing vector arrows. Turn the page when you're ready. Oh, yes. Yes. Because those vector arrows are in opposite direction. The 8 and the 3, is that what you're talking about? Okay, say it again, Miss Eva.
Because 8 and 12, I understand that you're adding back and both going in the same direction.
Yes.
3 is going in the opposite direction, so I thought you would subtract that.
I did. I did. And tell me if my math is wrong real quick. Anybody else? Y'all tell me my math is wrong. 8, I went ahead and just subtracted 8, take away 3, should be 5. And 5 plus 12 is 17. And that's where I get 17 from. Does that make sense? Or you could 12 plus 8, which is 20. 20 take away 3 is 17. However you do it, I still get 17. More than one way to skin that cat. So 17 is what I get from that one. Turn the page, and the next page, I'm going to do a practice problem, and then we need to get to the next part of our right triangles for our homework. Let's try a practice problem. It says here, while following the directions of a treasure map, a pirate walks 45 meters north, then turns around and walks 7.5 meters east. Okay, now this is our math problems in physics. Our math problems in physics, a lot of times it's like you got to visualize what's going on. So when in doubt, draw it out. That's what my saying is in physics. When in doubt, let's draw it out. I like to visually see an image, and the majority of the time for physics, they're not going to give you an image. They're just going to give you words. What is the single path straight line displacement look like if this pirate, instead of doing all of this business, just walked a straight path? And then it says here, draw it and then answer and give me that answer. So in this situation, if the pirate started off north 45 meters, that is my 45 meter north vector arrow. Stopped and then went east 7.5 meters. That 7.5 vector arrow should be and better be on quiz day a lot smaller. So I'm going to do that one. 7.5 meters. Again, I don't have to write the word east because the arrow indicates the direction of the vector. But it did say, what would draw out that straight line of the displacement of here. So it would be, my line may not be perfectly straight, but I'm going to try. That's what it would look like. And then it says answer it. Well, I don't know about you, but when I look at this, I see that there was a right triangle or a right angle that was produced. And when that 90-degree right angle is produced, then I know that I can a squared plus b squared equals c squared. Now, this is leg A and leg B because my unknown is my hypotenuse, which is leg C. So this is what we need to be able to do. I think those are pretty easy cheesy. It does not matter if you put 45 square or if you put the 7.5 squared first. It does not matter, right? Either way, you're going to come up with the same answer even if you flip them. All righty, let's turn this, move this up to the next spot. I just wanted to make sure that I went over a practice problem because then we have a little bit more. We need to take this practice problem to the next step, and that's what we're doing now. We're about to take this practice problem to the next step with our SOHCAHTOA. So let's go ahead and let's move to this portion of our notes. Now, again, I do not know what math class you had before here. I don't know if you had geometry, algebra 1, algebra 2. I don't know. You might be in pre-cal, and you are amazing. But some of us don't have that opportunity. Sometimes your math teacher may have been missing or there was a long-term sub. So here's what I want to make sure I start off with. First thing is, when you're looking at your right triangles over here, you need to be able to label your right triangles. I promise you, I will not give you right triangles on the questions. You will be given words. So you need to be able to draw your own right triangle by drawing out what the words say, number one. Number two, you need to identify the legs, okay? We have the opposite, we have the hypotenuse, and we have the adjacent leg. Do you remember those legs? Now, if you were not taught this way, I completely understand. But I like to start off at level 0. Just in case if some of us are not sure. Here's how I identify my opposite leg, my hypotenuse leg, and my adjacent leg. So wherever that right triangle is, if I draw an arrow to the other side, that leg is always my hypotenuse. Do you remember that? Hopefully you do. If not, here you go as a review. Get that right triangle, go to the opposite side, that is my hypotenuse. Get your right triangle, that 90 degrees, make an arrow, the leg that it points to is your hypotenuse. Now, we are going to start talking about thetas. A theta is the angle. We're going to talk about angles. We got to talk about angles and thetas now because our next unit is going to be over circles. Oh, circumference and all of that with a circle. Okay, so right now, if this little thing right here is drawn for you, I will not draw this out for you to show you where your theta is. This is identifying your theta or the angle that we are either looking for or the angle that was given to you. One more time. This identifies the theta. The theta is going to be either the angle you are looking for or the angle that was given to you. So let's go ahead and let's do that. This is my theta right here. On my theta and my right 90-degree angle is always my adjacent leg. Do you recall that? I hope you do. If not, it's okay. We're all doing this together. Find your theta and your right angle. That is your adjacent leg. Your theta and your right angle is always your adjacent leg. And then your leg that you have left over is your opposite leg. The leg that's left over is your opposite leg. Okay? Now, if you learned this right triangle a different way, then do it your way. But some students were not taught this. And believe me, you're going to have to do this on your own without a triangle. given to you. Okay? I'm going to go ahead and leave the next three for you to do on your own for practice because this is going to be like homework. Turn the page. Here we go. We're going to start off with Noah, and we're going to go all the way around the room. So we're going to go 1, 2, 3. Noah is going to start us off. We're going to keep going over there. This row right here is going to be Chris because 1, 2, 3. This is going to be Chris right here. And then we're going to come back up to the front and we're going to hit Miss Kim. And then we're going to go to Diva. If I was you all, I would practice because I'm starting off with Noah. 1, 2, 3. We're going to go end up with Chris and end up with Diva. I need the answer. If I was you, I would practice and double check them. Let's go. I need Noah to give me the sign of 25 degrees because I can't be here to baby you when you're at home or you're on the quiz on your own. You need to actually know how to figure out that sign of 25 degrees. What is the cosine of 53 degrees? What is the tan of 34 degrees? What is the sine of 22 degrees? What is the tan of 83 degrees? Not only that, but you need to know how to push it into your calculator. Just as you walk out of the house with your cell phone, because that is probably for, people, the most important thing in this world is to have their cell phone with them. I don't know, I walk out with my cell phone all the time. I do not need it. I don't want nobody to get a hold of me. There is nothing that important that you've got to get a hold of me. And if it is, I'll figure it out and learn about it later on. I'm okay. So go ahead and figure out what those angles are, those thetas. We're about to go around the room and you're about to call it out loud. Whether you're right or wrong, you need to give us an answer. And if you are wrong, not a problem. We'll figure out how to do this better. But we've got Noah. We've got Logan, you, because you're right behind Noah. Oh, yeah. We got Caleb's. We got Chris. We got Miss Kim. I just don't know Kim. Let me go. Beltron. And then we got Diva. All right, if I was you, I would go and double check them. Are we ready? Let's go ahead and let's go through this. I'm going to write all the numbers, and then I'll tell you if they're right or they're wrong. Let's go for it. Noah, what'd you get?
0.42.
Logan, what'd you get?
0.601.
Point what?
0.601.
01. Okay. Kayla, what'd you get?
I don't think I'm doing this right. I got -0.62.
Negative 0.62. Whoa. Why are you helping him out? No, I'm kidding. Chris, what'd you get? Speak it with passion.
-0.008.
-0.008. Man, you're killing me. Kim, what'd you get? Don't ask. Tell us.
I don't think it's right, but I got 8.14.
Okay, first thing is, I really cannot stand it when y'all kids doubt yourselves because she's 100% correct. You did right. Diva, what'd you get? 0.01. Okay, so let's pause for a moment. We are going to doubt ourselves, right? Why? Because we don't want to be wrong. Because we came from whatever school district and we were probably in pre-AP, AP classes the whole time, honors classes, and what we do is get nothing but straight A honor roll, which is great. I'm not saying anything wrong with that. But I am saying this class is going to challenge you, okay? And I know, like, how many times have I said you're smarter than the calculator? The orders of operation is what's going to kill the students, not the calculator. It's
It's because you typed it in wrong. I'm going to say right now, Kim, you were 100% right. It is 8.14. It does look a little funny. It looks a little funny here because all the other numbers are decimals, but don't doubt yourself. Don't doubt yourself. You are here because you are smart. You are here because you do work hard, because you care. Now, let me give you a hint. The only hint that I can guarantee you is that you'll never have a negative. Okay? Oh, I know, I'm so sorry, Chris. You will never have a negative. So let's go ahead. This number is correct. This number is correct. This number is correct. That number is correct. Our two negatives are not correct. Now I'm going to pull up my calculator, okay? And I don't know, but if you don't have an actual graphing calculator, then you need to bring it. What I was saying earlier is like when you walk out of the house without your guarantee with your cell phone, you need to guarantee walk out with that calculator every single day, especially if you have my class. If you're coming now on to my class without a calculator, shame on you, okay? Shame on you. You're a big kid. I shouldn't have to hold your hand and tell you to pull out your calculator. From here on out, when you sit down in this class, you break out that calculator, okay? Because there's a couple of you that sit here in this class and you break out your cell phone. I don't even see the calculator next. If anything, put your cell phone here and then put the calculator next to it. I mean, come on now. You're at college, okay? This is part of your tools that you should have, okay? So break out that calculator. Let's turn that calculator on. Now, hopefully we see there's the sine, the cosine, and the tan. But let's pause for a moment. I have my calculator on, and this one says 22 sine. Oh, sorry. Look, I screwed that up. Sine of 22. I like to close the parentheses. I know you don't have to. I got a negative also. There's a problem. This right here is degrees. And so some of you, the two of you who got negatives, you probably know now that your calculator is not in the correct mode, right? Somebody probably told you, hey, you're in the wrong mode. There's normal, scientific, and engineering mode. There's rads, which we're going to talk about next unit, and there's degrees. Isn't that degrees? So go and make sure that your calculator is in degrees. Hit enter, wherever that is, down here. Hit enter. Now I'm flashing on the degree mode. I'm going to clear it. I'm going to come back to sine 22, close parentheses. There goes my right answer, right? 0.37. Scratch that out, 0.37. Chris, do you want to give me a new answer? I'm sorry, was this Caleb? Oh, sorry, Caleb, I just saw the C. What's the answer here? 0.67 is the correct one. Yep, 0.67 is the correct answer. Absolutely. So now, did we take a little lesson home? Yeah. When we're starting to use the degrees, we need to make sure that our calculator's in degrees. Okay? If we're not talking about degrees, our calculator needs to be in rads, or could be in rads. Next unit, we're going to go from rad to degree within one question. So you need to go back and swap it and change it within one question. I know, craziness. Here, get that off. So here we go. As a reminder, just in case some of you, and I know we need to leave soon, but I know there's just so much physics that we have to do every day. If you do not remember what SOHCAHTOA stands for, it stands for the SO. SO stands for the sine of the theta equals the opposite leg, and that's the reason why we do need to know which one is opposite, over the hypotenuse. The CA, so I'm going to call this number 1, number 2, and number 3. Number 1, number 2, and number 3. The CA stands for the cosine of the theta And you can tell now that my theta has a line that's horizontal and my zeros have a line that's vertical or at an angle on them. So that is a theta equals the adjacent over the hypotenuse. And the last one, the ta, is the tan of the theta, oh, I better be in degrees, not rad, equals the opposite over adjacent. Alrighty, hopefully you remember that. SOHCAHTOA. Part of this over here, before I get to this part, let's look at this. That symbol is a theta symbol. One more time, that symbol is a theta, which means degrees. Okay, which means degrees. Other than that, this part, let me double check my homework because I don't want to let us go. Oh, wait a minute. We have 10 more minutes. No, 5 minutes, right? We have about 5 minutes, 3 minutes. Here's what we're going to do. On homework number 3, we are only going to do the front page. Homework number 3, we're only doing the front page. I'll put a note on D2L and email everybody. We're stopping right there, but for homework